Lesson 8.2, Properties of Parallelograms. First of all, what is a parallelogram? A parallelogram, as you probably can remember from a while ways ago, is a quadrilateral with both pairs of opposite sides parallel. So let's get that. Quadrilateral, I'll abbreviate quad, with both pairs of opposite sides parallel. Remember, parallel symbols are these like arrowheads there. Those aren't congruent marks, those are parallel marks. So that is what a parallelogram is. Now from this, you can garner a whole bunch of additional facts. It's a parallelogram. We end up with opposite sides. Here and here will be congruent, and here will be congruent. So opposite sides are congruent. And again, just to repeat, that would look like this. If this is my parallelogram, and this is congruent to that, and this is congruent to that. Continuing here with a kind of an example problem here. If we're told that this is a parallelogram, then I know that this is congruent to this, 11 is congruent to x, so I can simply say that x is equal to 11 and y is equal to 8. Alrighty. Another theorem relating to parallelograms. Opposite angles. So again, if I draw just a standard parallelogram, we know by the alternate or consecutive interior that if this is 80, this would be 100. And since we're parallel as well the other way, we can get 100 here and 80 here. So that means opposite angles are congruent. Alrighty. Now again, if we have a parallelogram, these are opposite angles. So I can say that this is congruent to this, which sets up 4n equals 76. Divide by 4, we get n equals 19. So again, a second property, an additional property other than the definition properties. Continuing with Theorem 8.5, like I had shown you earlier with my example here, if I have a parallelogram, and I guess I'll have to go 3 here, that, remember this was 80, this could be 100, this is 100, this could be 80, so consecutive angles here and here add up to equal 180, and that works all the way around the figure. And two angles that add up to 180 are called supplements. Add to 180 degrees. And again, that goes back to the consecutive interior angles with parallel lines. We end up with supplementary angles. So with A3, if it's a parallelogram, I know that this is 136. And I know that these two have to add to 180. So I can say 180 minus 136 equals 44, which means this is 44 degrees, and this is 44 degrees. And again, part of that is a combination of Theorem 8.5 and Theorem 8.4. Continuing here, diagonals. Remember from 8.1, diagonals connect non-consecutive vertices here. So here's a diagonal, and here's a diagonal. Now just by looking at this, we can see they're not congruent, but diagonals actually, in fact, split each other in half. And the name for that is they bisect each other. An example of a problem with that property, since again it's a parallelogram, we know that those two pieces are congruent, so we can say that 3x plus 6 plus b equal to 12. And likewise, we get those, so we get 2y plus 9 equals 27. When we solve for the variables respectively here, we subtract 9, divide by 2. Over here with the red equation, we subtract 6 from both sides, and divide by 3 to both sides, and we get x equals 2. That concludes the formal notes for section 8.2.